you could say there wasn't much of design really in the 70s, and not many collective co-designers thought of themselves as designers. We called it the collective resource approach, and co-design or participatory design, did not start formally to exist until 1990, so we're still long before that with the conference in Seattle, but I'll come to that later on. So we move into the 80s, and one of the things that had happened was that, okay, it seemed that people actually could have some influence on the technology and work organization by negotiating, but could they also be part of designing the new artifacts, the new technology? Could there be a way where people could actually be co-designers, not only people who putting up requirements, but also be part of the design process? We were very interested in that question and approached the office workers union with the idea that the offices were probably the next place where rationalization would take place, but they didn't see that as a threat. But instead, the workers at the newspapers, the printers, the graphic workers, and their union, they were very worried about the new technology that was coming in, so they wanted to work on to see another technology that were skill enhancing rather than de-skilling of the work. So this is the area we come into now, and this is also the area where industrial design comes into co-design, where architecture and urban planning starts to be part of co-design, the design methodology movement, Donald Schoenen, the reflective practitioner, as we talked about the other day, and many other things start to be part of it. So if the first move of co-design place of co-design was in Oslo, now Stockholm and Aarhus in Denmark start to be places which are locuses of this change. And when we come into the 80s, the mid-80s, or the first half of the 80s, the computer looks like this. This is the Apple Lisa, who came in 82, and this is the first Macintosh that came in 1984. So most of the things I'm talking about now happens before this, before 84. So the Graphic Workers Union, they were very worried in the Scandinavian countries. They were very worried about what's going to happen to them, because as they've seen in the US, the Typographers Union has been smashed, and in the UK, Rupert Murdoch, the media mogul, had closed the Times and opened a new factory out in Wapping, firing all the typographers and hiring electricians to do the work. So they were really eager in looking into, could there be alternatives? And I'll talk more in detail about that in a bit, but I think the best thing to start is to see a little film clip from then. This film, I'll show you a few clips. We see like 15 minutes or 10 minutes. It's produced by American West Coast film producer called Larry DeRessa, who did films on migration and social change and different problems that were already at that time an issue in California. And they were interested in what they thought was the Scandinavian approach to computers. So we take a look at that.
More than 50% of all Americans work with a computer system each day. Virtually all these systems have been designed with the idea of replacing or representing a task previously performed by people with a set of formalized computer algorithms and heuristics. While such systems have given us unprecedented data processing capability, they have unintended long-term effects in their larger environment, often displacing workers, de-skilling jobs, fragmenting the work process, and inhibiting creativity. So dominant is this representational model that computer advocates and critics alike assume that this technology is predetermined to replicate rather than augment human intelligence. In Scandinavia, an alternative paradigm for computer system design is emerging from a number of pilot projects. Starting from the conviction that computers should be used as part of larger organizational and social objectives, a growing number of Nordic systems designers, working with joint labor management committees, have begun to think about computers not as automation, but as tools for workers. In this program, we will look at 3 of these projects where computers have been designed explicitly to enhance, not degrade workers' skills, to create new services and jobs rather than simply automate existing work, and finally to encourage rather than inhibit participation, communication, and initiative within organizations.
We move on to
why has this new approach to computer design flourished in Scandinavia? In Scandinavia, over 80% of workers belong to unions. Although corporate ownership remains overwhelmingly in private hands, unions have won the right to participate directly in many decisions most Americans still regard as management prerogatives. An important example is the codetermination legislation, which gives unions the right to ensure that technology is implemented in ways that benefit workers as well as the company.
We have the right to information before any decisions are made. The right to negotiate and participate in the development of technology in your workplace. The right to have workers' representatives. And the right to have education about technology for workers and their representatives.
In our next example, we will see how Nordic graphics unions took the initiative in developing a computer system which would allow them to make a higher value-added product, thereby enhancing productivity, maintaining high wages, and saving jobs. Newspaper workers have long feared computerization as a threat to their craft and their jobs. At the Washington Post, pressmen smashed new computerized presses in 1975. In 1985, media baron Rupert Murdoch built the world's most automated newspaper plant so he could print his Times of London without skilled union craft workers. At Stockholm's Aftonbladet, one of the city's largest dailies, we can see the prototype of a radically different approach to newspaper technology. Like almost all newspapers in the world today, Aftonbladet is printed by the offset method. Traditionally, the process of creating the plates that print each edition of the paper starts in the newsroom, where an assistant editor makes a sketch of each page, indicating where stories and photographs should be placed. Graphic artists work from these page dummies to lay out precisely the actual photographs and text galleys. Newspaper graphic workers are highly skilled and well paid. Recently, however, new computer-based equipment designed to automate the page layout process has become available. Using these systems, text and images would be positioned by the assistant editors who did the page dummies. Graphic artists would either be eliminated or be left with jobs that provided no opportunity to use their skills or creative judgment.
What we saw was that the systems that existed were not built on the professional knowledge that a graphic worker has. Everything is very simplified, so they can use an unskilled labor force. As a final product, you get a very standardized newspaper that we think looks cheap. We saw systems where you did a full-page layout by filling boxes, and you didn't utilize the knowledge that graphic workers have in order to make a very good product. We felt that one ought to develop a technology that could use the professional knowledge of graphic workers. And from that point of view, we contacted the researchers at the Center for Working Life.
The Center for Working Life is a unique, government-sponsored research institution which assists unions and management in implementing co-determination. Responding to the concerns of the graphic workers, the Center for Working Life initiated a research project called Utopia, drawing participants from universities and labor unions from throughout the Nordic region.
The catchwords were quality of work and product, and by that we emphasize that the quality of the products was an interest of the producers and an interest of the trade unions, and also that just as important goal was the quality of work, the work organization, the skills of the worker, and that there was a connection between the two. So the technology that should be produced should be skill-enhancing tools rather than de-skilling automation.
This unusual goal of creating a computer system that functioned as a tool for extending existing skills forced the Utopia project to invent new research methods. They didn't start by looking for ways to computerize the page layout process. Instead, the research team began by asking graphic workers what new computer tools would help them manipulate graphic elements more easily, give them new creative possibilities, and allow them to produce a higher quality final product.
As computer scientists, I think we carry a heavy load of, say, different techniques that we've learned. Computer programs can be described as, say, formal descriptions. We think that we can walk out and we can study what other people do, their work, and then we can make some kind of formal descriptions of their work. And we found in the Utopia project that that kind of techniques doesn't work at all. There need to be a more direct dialogue with the users who are to take part in the design process.
The computer scientists and graphic workers of Utopia created a mock-up or simulation of an ideal computer-based newspaper graphics system, projecting slides of actual text galleys and photographs to test different methods of manipulating images to create the best possible newspaper page.
Here is composition work or page makeup work on the screen. You see the work material here, and down here you have the screen menu, and from the screen menu you choose the proper operations and the proper tools.
In 1982, the opportunity arose to translate Utopia's ideal specifications into a practical computer system by cooperating with a Swedish company that was planning to build a new computer-based newspaper text and image processing system. Known by the name TIPS, this system is now being tested by graphic workers at Aftonbladet.
We've tried to avoid using engineers' terminology, computer freak language, creating a user interface with commands, menus, methods of operation that are similar to what they are used to working with, and still taking advantage of the computer technology. For instance, we are working with masks for cropping. We're working with pictures. When they look at them on the monitor screen, it's just like looking at pictures laying on a light table or a light box.
By implementing traditional graphics operations on the computer, TIPS not only offers increased speed and precision, it also opens up a range of new creative possibilities. For example, the user can easily reverse a photograph or modify its brightness and contrast. The page layout facility of TIPS implements Utopia's specification that users should see a full representation of text and graphics rather than the empty box representations used in most other systems.
TIPS är ett mycket bra system.
TIPS is a very good system. You see what you're doing with the picture, which you couldn't see before. The greatest advantage with tips is that you can see everything that you do, so that you know what the end product is.
Vi lärde oss att acceptera inte
We learned not to accept the limitations of existing technology, but to reinvent it and win back the graphic worker's position when working with computers.
när man jobbar med bildskärmsteknik.
We have to design the computer applications to function as a tool. That is to say that it should be built based on the tradition within the craft, be based on the skills that people have, be under their complete control, and so to say be transparent, so the worker works with what he really should do, not with a lot of buttons or things that come in between him or her and the workpiece. That's a tool. And that's a design ideal. It's not to say that the computer is a tool, but that we should try to make computers function for the skilled worker as a good tool.
The three projects investigated in this program grow out of a distinctly Scandinavian commitment to democratizing economic life. They reflect a deliberate social strategy of making human resources the cutting edge for national productivity and competitiveness. At the same time, a growing number of American computer scientists have begun to focus on what is often called applications-based systems, or end-user computing, systems which augment rather than supplant human intelligence. These parallel experiences suggest that in the end, the most productive and efficient use of computer technology may well be that designed to be part of larger, non-technological social systems and to address broader democratic objectives.
So, can we say that Scandinavia was like a starter of doing these kinds of software graphic?
No, we cannot say. What you can say is that there is a very interesting connection between Silicon Valley and Scandinavia. Just to answer shortly now, that the key hub of these kind of technologies in Silicon Valley in the 80s was Xerox PARC, which was a research center, and they were very forward because they did not only hire computer scientists, they hired architects, they hired anthropologists, they hired teachers, etc., in trying to find ways to design computers that were more useful. And they also looked at Scandinavia. We looked at them because that was in the forefront of making the computer technology more useful for everyone. And they looked at Scandinavia because of this idea of looking at broader perspectives on where this could fit in. And I can show you a picture here. This is a quote from MIT Technical Review in MIT Technical. That's where later on MIT Media Lab and everything evolves. So they wrote, "So the impact of Utopia is continuing to expand, and the idea that workers and their unions have an important role in the design of new technology is reaching a wider and wider audience. Today Scandinavia, tomorrow perhaps the rest of the world." As we know, that did not happen, but there were kind of interest in these kind of broader perspectives. And you can ask, why didn't it happen? But I want to go back a little bit. So as you saw in the film, we were confronted with the problem of being expert designers. So we did blueprints, flowcharts, all the kind of design requirements, and they would say, this is great. But it turned out that there was no dialogue. So that's when we started to experiment with mock-ups, prototypes, games, etc., which became part of the participatory design movements and its repertoire. So here's our first version of I mean, you have to think that no one knows what a PC is. A PC does not exist. When you're going to discuss with people how should this thing that we don't know yet, how is it going to look? And you have a little bit of experiments from Silicon Valley on things you can show. But so the first tryout was, this is just a sheet of paper on the wall, and here's another sheet of paper, and on the desk in front of it we had a box filled with rubber, which was the mouse. And people could start, what if we have something like this? How would you do it? And in a later version, because we could not do prototyping on computers, because we didn't have that kind of computer, so we build up a model of this in cardboard and with background projection. So people would come in then and try this out and see if is this a good mouse? Is this, when I want to do the work, how does scale work? How does contrast work, etc.? And you would sit and discuss that. And you also would sit and discuss how do I collaborate with the people around and learn from that. I won't go into the theory of it, but so for instance, you have to imagine that in 1981-82, no one in Sweden, or very few people in Sweden, knew what a mouse was. The most famous mouse in Silicon Valley was big as a block of a brick. But things started to come, and what would be a good tool for a graphic worker? So this was just a repertoire of mouses, mock-up mouses that we did and had to try out. And I was particularly in favor of this one, which you kept in if you're right-handed, in your left hand, and then you had the right hand free for working, but wasn't implemented. So other ideas were stronger. Well, what was developed was a number of these mock-ups and games. Here, for instance, an early example of a production game. So these are designers and graphic workers sitting down to do a new layout of the production facility, and the different cards, some are tools, some are materials, some are flow, etc. I don't remember all the details, and some are qualifications, and you discuss and build the flow out of that. This one was something we saw later on. We saw it in also in the US, but not in Silicon Valley, something that they called a desktop laser printer. And this is in 83, 82. At newspapers, they have had photo printers. They cost about 1 million Swedish crown or more, and they print on film. So it's pretty expensive. You're not allowed to, once you print, you print. You don't do a lot of drafts on it. So they had something they called a desktop laser printer down in the basement as a prototype, and they suggested that it could print on normal paper, and the cost would be maybe less than 200,000 Swedish crowns. So, okay, if it came down to 100,000, maybe you could change the work organization, how typographers and journalists work together. So this one, this mock-up, this prototype was just part of an organizational game where you tried to see if you had a cheap device like that, how could you organize work compared to the traditional one with the photo setter. So it's a lot of these kind of things that were happening in terms of the repertoire of methods for participatory design. Maybe I should move to this picture and the quote and tell you what happened. First of all, in 1984, the Macintosh came. A system that we've been part of designing and developing was, in the several 100,000 per machine. And then comes the Macintosh, who is only, I don't remember at that time, 20,000, I think it was the first Macs that came out. And with software that was really cheap, so they kind of won the competition. Not for professional systems at that time, because then there was an Israeli company. There was a lot of investment in this for Scandinavian circumstances, but the investment in Israel were much, much bigger, and they won the professional competition. You remember what I said about Lucas Airspace and the plan for alternative production? During that time, they moved on, and in London, the young Labour people were in power. Really young people being in power in the Greater London Council. They had something they called the Greater London Council Enterprise Board, which was kind of, you could say, a social incubator or an enterprise incubator for socially useful production. And the leader of that was also the leader of the plan for alternative production, the union at Lucas Airspace, Mike Cooley, who wrote a famous book called Architecture B. So he's a worker, but very well educated, speaks perfect Oxford English. So it's this kind of strange person. But they've organized this Greater London Enterprise Board, and they have one company called Whitechapel, who knows how to do things with graphic interfaces. And they are part of Greater London Enterprise Board. And Cooley connects us via the Greater London Council and said that maybe they have the technology that could be used to produce the specifications that had been developed together with the graphic workers in the Nordic countries. So this is really, really interesting, and it all get abolished when Margaret Thatcher decided to abolish the whole Greater London Council. And so this is, it's quite, I don't know if everything could have happened, but it was the start of something that was not only local and not only Scandinavian, but with networks of alternative production coming on, but very clearly stopped at the time when neoliberalism is becoming the new dominant paradigm, not only in the UK, but also, as we'll see, in Scandinavia and many other places. So this marks, in a way, the beginning of a new era in participatory design. The conditions are changes. It's not anymore a lot of focus on democracy at work. It's not anymore a lot of focus on skills and influence, etc., but more on a certain kind of economy. So, if I wrap up what kind of knowledge regimes, you say that was in the 80s things started to change. It was not like the 70s, but very open to democracy. But there were new kinds of alliances between Scandinavia and US. And in terms of knowledge regimes or ideas here, some basic ideas to understand this with skill. It was very much influenced by the work of Donald Schoen that we've been talking about before, and how people are reflective practitioners and how they can be supported by that. And many ideas about, to follow a rule in practice, I dropped that, but new theories on how to understand what collaboration is, and the fact that we can actually do things together without actually understanding one another, as long as it's meaningful for everyone that acts. And a lot of of focus on new ways of playing in reality with games, with mock-ups, with prototypes, etc. And there was even forum theater as part of the repertoire of what the co-designer could do. So the 90s is very different. It's business as usual in many ways, but it's not any big breakthrough in terms of design at the workplace or in society. But there is this merger of Silicon Valley and Scandinavia. At that time, it also a lot moves to Aarhus. Aarhus becomes the hub of critical design, at least critical participatory design. And this is the time when we get the first portable Mac. And actually there was one much bigger before. And so in a way it becomes much more academic in these days. And as I said, already in the Utopia project you heard that industrial designer and architects started to be important partners in the co-design. You could say that, to me at least, the most interesting thing was this meeting between California and Scandinavia in terms of participatory design. And so in California, there was a group across all the big IT companies, and the big IT companies at that time, there was Xerox, it was HP, it was Silicon Graphics. Many of them are dead. HP is not dead, but many are dead, and many of the companies that we have today did not exist yet. Apple was coming up. And many of the people working in these companies, and people also working at Stanford University and at Berkeley, were part of something called CPSR, Computer Professionals for Social Responsibility. It wasn't a union, it was a meeting group for people in this field, in the high-tech area, who wanted to work towards social responsibility in their work. One of the leaders of this was Terry Winograd, who was kind of the love tech child of Stanford at that time, early artificial intelligence guru who reacted the whole idea later on and tried to do something completely different. And Lucy Suchman came on, who I'll say a little bit more about, who was the kind of the anthropologist that came in and reformed how we work in participatory design. So they were interested in what was happening in Scandinavia, and vice versa. They were a port into the high-tech industry in Silicon Valley. So there started to be an exchange between California and Aarhus, basically. And so people came in there, stayed for half a year, etc., and the field developed in this collaboration. So this is very much more a theoretical period where one of the key actors is another anthropologist called Jean Lave, who had studied skill development and power in different countries and in different situations. She's been working with people doing the cork in Portugal, and she developed a concept of legitimate peripheral participation. It sounds very strange, but basically it says that it's an idea of how we can learn from another and how we learn in practice by being confronted. That we don't take the way via first learning the formula of how to do something and then do it. It's more about, like, for instance, you could show that people are very, very capable of going to the supermarket and shop and know exactly what the costs of what they are without never having had a lesson in math or calculus. So there are obviously other ways where we can achieve these skills. And she also looked into how the power game when we learn, how there are old guys like me who dominate a lot, and then in the end you you push us away. Little bit more sophisticated than that, but basically this power game that goes on in terms of knowledge. And her idea, what we could take from that is the idea that when someone enters a new community, when you enter the community of those that you're going to work with, or when they, vice versa, becomes part or enters your community, then the conditions for the newcomer become essential. So how do you support for the newcomer to be part of your community of practice or share something of it, and vice versa? And what kind of methods can support that? And this is also where a lot of the games come in.